What we're going to chat about today here is really this new guideline that was pulled together by ASHRAE in a very quick fashion. If those of you that can squint good enough or have a big, large display, you'll see the detail on that right image there. That's the header page for the ASHRAE Task Force for Schools and Universities. It was released back in the middle of July, of this past July. And what ASHRAE wanted to do is, basically, participate by pulling together their engineering resources out of Atlanta and coming up with a guideline whereby they can then, instruct schools across the country, and not just high schools, but grade schools, middle schools, and up to colleges and universities. But basically, to what can they contribute to optimizing the performance of an HVAC system in regard to helping to mitigate the spread of COVID-19. And one thing they realized was that looking at a lot of the medical research, it was quite evident then back in March, April, and May that this was not just contact transmittance, but also airborne transmittance, and hence the reason to optimize HVAC by, number one, increasing outside air, number two, increasing the outside airflow to the point that you're actually trying to mitigate and dilute the airflow down. And a way to keep track of that is by actually looking at the CO2, relative humidity, and temperature in these classroom spaces or any occupied space in a school. And that this new guidance should be applied across all climate zones, across all districts nationwide. And a lot of the underlying data, or I should say recommendations, really rolls back to what's called ASHRAE 62.1, which is ASHRAE's ventilation standard for all types of commercial buildings, excluding residential homes. One of the biggest things that they found out was that once when we speak, when we exhale a lot of water vapor, we exhale carbon dioxide, and within those water vapor droplets, though, resides the viral particles. And what research had shown on the medical side was that these viral droplets, vary in size. And that size is kind of depicted there in that graphic on the right-hand side, which basically shows you that, the smaller that droplet becomes from 100 microns to the right, all the way down to 0.5 microns on the left, the time aloft goes up exponentially. And this is really a function of a physics law called the Stokes law, which has to do with the decreasing area and diameter of a particle moving through a viscous fluid like air. So the viscosity of air is really dependent upon the amount of latent heat that's in the air, which is a function of how much moisture content is in the air. So this is where we get to relative humidity, right? So the higher the relative humidity or the lower the relative humidity has a great implicating factor in how large these droplets stay or how small they become. And as a result of that, ASHRAE basically stated that, hey, we've got to monitor relative humidity and CO2 in all these spaces, collect the data, and also baseline and measure the parameters of the existing HVAC system compared to how it was set up when it was first installed. So when we look at, number one, we're going to take a look at the humidity aspect. Number one, what's the linkage? The linkage is that, if you've got too low or too high of humidity, and it really depends upon the geographical area of the country that you are in, but it's also seasonal as well. You can see, as we exhale there on the right, these droplets, as we exhale, they start off that 100 micron size. And just for relative perspective, I'm going to go back one slide for a second. That 100 micron size, that's about the width of a human hair, a little bit larger than the width of a human hair. So, quite small to begin with. But if you're at 40% relative humidity in a space or lower, those droplets are going to decrease quite quickly, which is a good thing. That means they're not going to land on a surface and create a contact transmission aspect. But the problem is that it's more of a human body response issue. When the humidity in a space goes below 40% or so down to 35% or even lower, especially if you're in the Southwest, the ability of our body to actually create and produce fluid to expel foreign objects like viruses, bacteria, pollen. This is the reason why our eyes water in the springtime, the reason why we sneeze, the reason why we cough. That's our body's response mechanism to expelling foreign matter. And within that, our body must produce fluid to do that. So our body is really quite compromised in the fact that when relative humidity in the envelope that we are residing in goes below these levels, it really impacts the ability of our body to get rid of it. Number two, because that relative humidity is so low, again, going back one more time, the time aloft, it goes up to hours to even days when those particles become very small, down to 0.5 microns. And when you get down to that level, greater risk of those of that foreign viral particle actually depositing very deep in our lungs, and really impossible to get out at that point in time. On the high humidity side, like we have in the Southwest or the Northeast or the upper Midwest during the summer months, really above 60% RH, it's really difficult to prevent contact transmittance because those viral droplets stay larger because the amount of latent heat that's in the air, that's opportunity for that water vapor to be transmitted from that suspended droplet to the air through evaporation or desiccation. And those droplets will stay larger and they will fall faster. And research shows that when those droplets stay or land on the surface, depending on the surface material, whether it's cardboard or plastic, formica or stainless steel, viability of those viral particles in that droplet on that surface can be viable for hours up to many days. So not a good thing. So hence the reason to want to get a better handle on humidity control. Oops, sorry. Then come about 2012, the very first study came out bringing in this link between CO2 and COVID. But there was another factor here that compounded the issue of high CO2 in classrooms, and that is cognitive performance or decision making. This was first noticed by Lawrence Berkeley Laboratories back in 2012, and they looked at hundreds of schools across the country, and they found that there was a link between high CO2 levels and absenteeism and cognitive performance, but nothing that they can actually quantify like in a double-blind study to make it more scientific. Then about a year or two later, the National Center for Educational Statistics, which is really a part of the Department of Education, did a survey across the US, found out that across the 100,000 public K through 12 schools in the country, average age is 42 years old. So you can imagine the state of the HVAC systems in these schools that are multi-decade old schools. From a performance standpoint, leave a lot to be desired. As a matter of fact, the feedback that came back from these 2,000 school administrators that were interviewed was that 30% of those administrators actually rated the HVAC systems as being poor to fair in operation. Other factor here too is that windows in most schools of all ages are typically closed or sealed, even though they were designed to be operable, but for security reasons, to prevent vandalization, most of these windows are sealed shut. And then when you compound the fact that most of these systems are, as we said, 20, 30, 40 years old or older, pretty sure that those systems probably did not have functional or operating outdoor air capabilities to bring in fresh air. So come around 2015, 2016, Harvard, in concert with Syracuse University and Carrier Corporation, funded a study, a double-blind study that actually tried to nail down what is this true effect between carbon dioxide and cognitive performance. And what they found out in this research was that if they bring the CO2 levels in an enclosed space down from ASHRAE's standard of around 1,100 parts per million down to 600, that cognitive performance increases by a factor of about 62%, which is not an insignificant number. At the same time, when we look at the contribution that CO2 has, or relationship has, with COVID-19, the lower amount of fresh outdoor air that we can bring into a building space like a school is really a function of resulting in a higher CO2 number. So the relationship or the proxy to COVID-19 is the fact that if you've got elevated CO2 levels, you probably don't have enough fresh outdoor air to dilute that volume of airflow down such that the risk of transmittance would reduce because you have more fresh air mixing in with the room air in the space. So that's the reason why today ASHRAE states that the CO2 levels must be monitored and documented consistently in all schools, all classrooms that are occupied, to determine what the relationship is between that and potential infection of COVID-19. Because point of fact, the three things that we all exhale on a daily basis, well, I mean, if you're infected, but it's water vapor, it's CO2, and it's the viral particles inside the water vapor droplets. So when we kind of try to, pull together the entire scope of ASHRAE's document, as a matter of fact, if you want to look at the details of the document, I would just Google ASHRAE Epidemic Task Force, and that should bring you right to their website and to that link. Tried emailing it, but it's about a 70 megabyte file. It's 42 pages, so it's quite extensive. Anyway, this page kind of pulls together and encapsulates the entire document statement. So number one, they want all school systems to be baseline measured. That means, again, going back and measuring the basics, your supply, your exhaust CFMs, the pressure differential across all the filters in the system, relative humidity and temperature set points measured in the classrooms, measurement of outside airflow, if any, and how does that correlate or compare to the original set points that were established when the system was installed, back when either when the building was built or when that system was replaced. Going forward from that, the operational sequence, once schools open back up, is that you must purge that school for 2 hours before class and 2 hours after class with max exhaust air, max supply air, max outdoor air, basically a complete purge and a wash of that building. On top of that, during the school operational hours, control and maintain a minimum outdoor air volume of 10 CFM per person. That is in all common classroom areas, labs, hallways. Maintain and not to exceed 800 to 1,000 parts per million as a maximum number of CO2 in the occupied classrooms. And control that relative humidity between 40 and 60% RH, seasonally dependent, and also maintain the temperatures in this space in the mid to low 70s. Increase filtration to MERV 13, and we'll talk about that a little bit in a second. And then the installation of CO2, relative humidity, and temperature monitoring sensors in the classroom space, and that during all occupied hours, data should be collected from those three variables to be documented and to be actually submitted as a report to the district committee. And in fact, ASHRAE, yes, has actually, kind of tried to define what is a district committee. The district committee actually is an assembly of let's say the facilities manager of the school district, the head engineer of the district, probably the principals of the schools, maybe the president and vice president of the PTO or PTA. Basically, the group that would be concerned about the ability of the school systems to maintain control of these three parameters to help mitigate the spread of COVID. But that's not all. In addition to that, we all remember the old nurse's office in our elementary and high schools and grade schools. It's a little bit different today in the sense that now ASHRAE also wants the nurse's office and her adjoining rooms, like the testing room or an isolation room, to really be set up toward the ASHRAE 170 guideline, which in fact is a clean room isolation guideline for pressurization control. And as a matter of fact, the nurse's office and the isolation room to the right and to the left here need to be kept at a constant negative pressurization, all right, in respect to the corridor space, and that a positive protective room should be established that'll be set up as a positive pressurization space, again, pushing airflow into the negative spaces surrounding it. Why is that? So let's kind of walk through this scenario. A student comes walking down the corridor, complains of a headache or a fever. Nurse may administer the COVID test. It takes a while for those test results to be produced. So the nurse should be placing that student slash patient in this isolation or quiet room while she contacts the parents. Parents come in from outside the school envelope because they have not been part of the school environment. They should be placed in a positive pressurization suite or area that net flows airflow out to the surrounding spaces. And in addition to that, this entire zone needs to have its own supply and exhaust system, two modes of operation, occupied and unoccupied. And this will be a dedicated system separate from the school system. Okay. And ASHRAE 170 Table 6 is really that same specification, which talks about the filtration level needed for a isolation space like this. So point in case, we're actually, changing, the operating parameters of some school areas to really kind of mimicking that of a hospital isolation application. So where Testo comes in and can contribute to part of these measuring solutions is that number one, we've got technology out there to actually measure and quantify the baseline information required by ASHRAE to understand how the HVAC system is operating up front by measuring your supply and your exhaust in each of the runs going into all the classrooms, by measuring relative humidity and temperature in those same classrooms and CO2 levels, and actually providing a report that can be generated from this instrument, which is called the Testo 400, as a PDF report to the district committee and the powers that be in the school district. And then going forward, once again, as we said, once the building has been baselined, you go into an operational sequence mode whereby the school needs to start installing, the proper sensors for CO2, temperature, and humidity. And they actually mention in the document that it can be done one of two ways, or should by one of two methods. One, by contacting the local BMS or BAS supplier, such as Siemens, Johnson Controls, Honeywell, and others like that, to install this monitoring system, or to be provided by suppliers that manufacture sensors and data loggers like ourselves. Let's talk about that a little bit, because cost comes into play here, because most times school budgets are pretty tight, although many school districts across the country today now have allocated additional money to pay for these upgrades, either through bond issues that have been voted on, or tax changes in the school district or the county. But when we talk about a building management system or a BAS system, which typically supplies all the room temperature sensors in the building space, and they also do a fantastic job of doing everything from monitoring parking lots with CCTV systems, fire and security, alarm and control and access, card key access into the campus space, controlling the rooftop HVAC systems, and lighting controls and temperature controls in the space. But the difference is that the sensors that are provided by the building contractors are designed to measure and send an output to do something, either to open up a reheat valve, or to open up or close a VAV box, or to effectively change the speed of a variable speed fan motor, to change the supply air volume or exhaust air volume. These are measure and control sensors. That they are not measure and data log sensors. So as a result of that, it's a really different beast. Whereas Testo, we've manufactured data sensing technology for years, and it's really quite important that the system or the sensors that are going to be installed here in the school level really should be independent of the control aspect. Okay, that's a key thing. You don't want your controllers also being used to send and report the actual measured values in the space, because point in fact is that most of these sensors and the controllers can change the display output to make it look more stable than what it might be. They can change the PID control algorithm to also make the room space temperature or relative humidity or CO2 numbers not quite reflect what is actually being measured. So this is why, excuse my voice today, this is why it's really quite important to have an independent system, whether it's Testo or somebody else. On top of that, quite important also to have the option of providing NIST traceable certification of these three important measured variables in the space: temperature, CO2, and relative humidity, to make certain that what is being delivered as a monitored signal is in fact true and valid measurement. Okay. And next thing we're going to be talking about in the next slide is really using wireless technology as opposed to wired technology in a building space, which keeps the installation cost low, which will help facilitate the installation of these critical sensors to help mitigate the spread of COVID. So the way that Testo applies our technology, and you remember back in the slide back at the beginning, we spoke about the experience that Testo has in the biopharma life science industry for providing monitoring systems to data log and collect all these parameters of temperature, pressure, relative humidity, light illumination, part per million content of CO2, even UV irradiation, etc. Facilities that are either pharmaceutical compounds or drugs or food products, anything that human beings ingest, really has to be data logged on a consistent basis, such that if there's a problem in the manufacturing space, the manufacturer can turn over to the FDA, documentation to prove that the manufacturing variables in the building envelope where the products are being made have been consistently maintained to keep the integrity of the product high. So what we did earlier this year is that we moved the use of the Testo 160 over to the commercial side here at Testo to apply this same solution for monitoring these critical values to get a handle on CO2, temperature, and humidity in the classroom space. And it's been quite effective. One thing you'll notice is that the system is completely wireless. And number two, what's not quite noticeable in this graphic, it's also battery powered. That also keeps the cost low. When we look at some of the capabilities of it, the unique characteristic of this Testo 160 is that its ability to actually collect and hold data. So 32,000 data points can be collected and transmitted to the cloud, and then can be viewed in report form by the administrators or the PTO or PTA individuals. There are 4 sensors located inside this enclosure, making it quite a compact package. And you can actually have upper and lower alarm limits set that can be sent out either as an SMS text message or as an email alarm message out to the responsible parties that be. And again, 12-month battery power, which is a quite an advantage as opposed to putting in a complicated wired system. From a performance standpoint, I went back and we spoke about how NIST traceability is kind of a nice feature to have. So we can actually have this 160 is certified NIST traceable with a documentation paper to go with each one if necessary. But we got quite a wide measuring range for CO2 and temperature and humidity range. And it is a unique product in the sense that, again, all wireless, all Wi-Fi, and it's also encrypted Wi-Fi. But we also have the ability to actually, through an open API, which is an application, to integrate the output of this to the existing building automation system if there actually happens to be one in the school at that time. So low cost of installation, and the report format is either a PDF or a CSV report. So you can actually have a output that is either graphical or a tabular form. And I'm going to look at here a kind of a comparison of these costs. I talked about the cost of it being expensive. To do it through a typical BMS approach, we're going to look at that right now. So what we have here is basically the Testo 160 system here, and these are representative products by the big 3, Siemens and Honeywell and Johnson Controls. These prices, by the way, are all internet pricing that is fairly current as of a month or 2 ago. And you'll notice that the first cost does not tell the story. So if we take a typical example of 20 classrooms, and we've got these 3 variables in each classroom, so that equals 3 points of information. So a total of 60 points to be monitored. A typical temperature control contractor needs to cover the cost of the engineering time to design the system, to configure it, to program these additional points into the existing system that's on that building space, schedule it, install it, startup, and commissioning. Typical cost across the country on average is about $1,500 to $1,700 per point of information. So that's yes, per point for RH, CO2, and temperature. And that's excluding the cost of the devices themselves. So if we take these numbers, multiply them quite simply times 60 points, you're going to be running close to 6 figures just to implement the labor component of putting in sensing technology in 20 classrooms. By comparison, if you take 1 man-hour per unit for each 160 times, an average cost of about $150 of field labor cost if you have to bring in an outside technician, which you really don't. I'll talk about that in a second. Times those 20 units, we're going to be at a quote unquote install labor cost by a third party, which is about 1/5 to 1/6 this cost. Talk about this labor component. If you know how to go to your Lowe's or your Home Depot and buy a wireless battery powered thermostat and put the batteries in, register the system on the website, enter your password and username, and link up that thermostat to your home Wi-Fi router in your house, that is essentially the same commissioning procedure in short for like the 160. It is that simple to do. So when we look at the total cost, which is first cost plus installed cost, this is quite a huge difference in price. And as a matter of fact, that savings can be then applied toward providing and buying, PPE for the students, for the teachers, providing additional cleaning agents for the school and cleaning crews to come in and clean the campus or clean the school space. So quite an economic solution. There is a small charge for the monitoring fee, and it's quite inexpensive. To be specific, if we looked at these same 20 classrooms, it's about $22 per year for each one of these 160s. So we're talking about $90 a month for a school that actually has up to about 50 units. So about the cost of a monthly cable bill for your house to provide this monitoring data. But what it gives you is 24-hour access. Really important concept here is that you can actually have up to 10 registered monitors of the system. So you can actually have the president of the PTA, their PTO, the vice principal and principal of the schools, the town engineer. A number of people can be signed in to monitor what is actually going on in the schools, Wi-Fi, password protected. We talked about the battery power, which is long-lived, 12 months, and it's quite outstanding. This is a good example of the graphic and what the live display would look like. So here we're actually showing, temperature, which is, if I can squint really closely here. Okay, CO2 is the red line, and green is, let's see, green. Blue, it's absolute humidity. But you can actually define whether you want to show all 4 of these or just, 2, maybe just CO2 and relative humidity, but it's your choice. And it is quite flexible. You can actually identify the classroom numbers here to click into. The school can be identified, etc. So it's quite easy to hone in on a school or a room that has a particular issue from a contamination standpoint on the Testo 160 dashboard. And this is what you get with that monitoring package that I just spoke about in the previous slide. Case study. We are a German company, even though we've got a large U.S. presence headquarters here in the U.S. But we've had the product installed in Europe for quite a long period of time. This is a good example of one. FTS College of Precision Technology It's both a college and a middle school, about 600 students in 4 buildings. The challenge here was that, the buildings were, up to almost a century old, sandstone in construction, deteriorating insulation on the inside, with no outdoor airflow control and an antiquated HVAC system, which is not too dissimilar to the 40 and 50-year-old K through 12 schools we have here in the U.S. So they put a monitoring system in, and what they found out quite quickly was that over the course of each given day, the mean average CO2 ramped up quite quickly to exceed over 2,000 parts per million within 30 minutes of classroom starting. And the average high number was around 3,000 ppm, and actually peaking as high as 4,000 parts per million. So by implementing the 160 in all the occupied classrooms, they were able to receive text alerts to the administration, to the teachers. In addition to that, there is a silent red blinking light that would be activated on the 160 in the classroom that would be in question, which then notified visually the instructors to actually, open up a window to bring in more fresh air until the alarm would be inactivated and back to a reasonable level of CO2 in the room space. I realize I went through a lot of information here in a very short period of time, but I would be more than happy to entertain any questions that anybody might have right now. My contact information is here, email address and phone number, and I want to thank everyone for attending today. And again, happy to entertain any questions that anyone might have today. Thank you.